Welcome back to another installment of Physics in the Flesh, Conservation of Mechanical Energy 1. A monkey looking for her brother is running at top speed, 5.1 meters per second, and grabs a vine hanging vertically from a tall tree in the jungle. How high can she swing upward? Does the length of the vine affect your answer? Okay, so first things first, let's draw a picture. We've got someone running in the jungle looking to jump on this vine hanging vertically from a tree. So here's my ground, here's my tree, and you don't have to be an artist in physics. In fact, it's usually better if you draw something really simple. Here's the vine hanging from the tree, okay, and here's the person or the monkey running. Okay, that's the first step. The second step, you've got the tree, the person's swinging up, or the monkey, keep forgetting that, it's a monkey, and they're going to reach a certain maximum height. Okay, we don't know what that is, but we're going to try to find it out. What maximum height do they achieve? So this H. Now, I'm going to call this H2 because this is the final installment, which means I have to label an H1 as well. Okay, H1 is going to be 0 meters because that's where we start off from. Another piece of information we have in addition to the heights is the speed. Okay, so initially the monkey's running at 5.1 meters per second. So V1 equals 5.1 meters per second. And here's the thing, although they don't tell you the speed here, the maximum height is achieved when the speed is 0, because you go up, your speed gets slower, slower, slower due to gravity, becomes 0 for an instant, and then starts increasing as you go back down. So we can actually say V2 is equal to 0 meters per second. And if you want, just make a note on your sheets. Speed is 0 at the maximum height. Okay, so I'm going to use conservation of energy here because, you know what, I see something with kinetic energy, gravitational potential, and then a mixture of those two, how those two get interchanged. Okay, so I'm going to say, let's do a conservation of energy. ET1 equals ET2. Okay, so the two energies I'm dealing with here are gravitational, potential, and kinetic. So EG1 plus EK1 equals EG2 plus EK2. Okay, so the formula for gravitational potential energy is mgh, and since we're dealing with 1, it's going to be mgh1 plus 1/2 mv1 squared equals mgh2 plus 1/2 mv2 squared. Now, before you think that you weren't given a piece of information, we actually know everything here. Okay, so mass is an unknown, true, but you don't need it. Because mass appears in every term, imagine it being factored out of both sides, left and right. They would then cancel from the left and right. If you see a term in every single term, every single part, you can cancel it out. Okay, so there we go. The masses are canceled. Now, what else can we do to simplify this? We know that H1 is 0. Okay, so that makes this whole thing disappear. We know V2 is 0, so that makes this whole thing disappear. So this really complex expression is going to become something really simple and straightforward. It's going to be 1/2 V1 squared equals GH2. Okay. Now, what are we looking for here? We are looking for H2. So let's isolate for that. Okay, divide both sides by G. I'm going to bring H2 to the left just to make it look a bit cleaner. And essentially what you're going to get is H2 equals V1 squared over 2G. All I did is write the half as put the V1 squared in the top, putting the 2 in the denominator. Okay, so V1 squared over 2G, plug in your values. Okay, so V1 is 5.1 meters per second. That's getting squared, divided by 2 times the acceleration due to gravity, 9.8 meters per second squared. Okay, when you plug that into your calculator, you are going to get a height of 1.3 meters. Okay, so H2 equals 1.3 meters. And that is your answer. Okay, so the person or the monkey, why do I keep saying person? Okay, the monkey goes up to a height of maximum 1.3 meters. Now, if you take a look at the expression where we even found that, V1 squared over 2G, okay, that has nothing to do with the length of the vine. Okay, so what we can say is the length of the vine does not affect the answer. But there is a caveat to that, okay? Just think about it logically. You can reach a maximum height of 1.3 meters, right? So if you reach a height of 1.3 meters, then you're about here. 1.3. Now, if your rope is 0.65 meters long, let's say, okay, so let's say it was hanging and the rope is 0.65 meters. When you swing up, you can go to a maximum of another 0.65 meters, which is 1.3, right? But if the rope is less than 0.65 meters, let's say it's 0.55 and you swing up, the maximum you can achieve is now 1.1 meters, right? So yeah, technically the length of the vine doesn't matter, but it can't be less than 0.65 meters. Okay, so the length of the vine does not affect the answer. However, the vine cannot be shorter than 0.65 meters. And that is it to this problem, guys. I hope you enjoyed it. If you did, be sure to smash that like button and subscribe to Physics in the Flesh so you never miss a video from me. Thank you guys for watching, and I can't wait to see you guys in video 108, Conservation of Mechanical Energy 2. Hey guys, welcome to the end screen. Woo, I got you guys. All right, here's what I need you to do. Subscribe to this channel. Okay, I'll stop. Thank you guys so much, as usual, for watching. If you guys enjoyed this video, be sure to subscribe to my channel by pressing that red subscribe button below and smash that like button so that I know what I'm doing makes sense to you guys. First face reveal I do and my hair is all frizzy. I post new videos every weekday at 12 noon. Finally, guys, I love you so much for watching. Please continue to do so every weekday at 12 noon.